Dear students, welcome back. This is Dr. Biju Vasudevan. In this video, we will discuss chapter 12.2 Fourier series, which is following for week 11. Week 11. So, what is the concept of Fourier series? You see, in this picture, you can see the front view is given in blue, and the pink color represents the top view of a wave, a combination of different waves, isn't it? So when you see from the front, you will notice only this shape, which is given in this blue. But from the top angle, you can see on the behind of this front view there are many different functions, different sinusoidal functions, either sine or cosine functions. So what we are going to do here, any function any function f of x that satisfies certain conditions called Dirichlet's conditions. We don't have those conditions to verify right now. We are not verifying the conditions in this chapter. We are assuming that all the problems given to us are satisfied by this condition. Right? So which is a function which is periodic and satisfying these conditions can be expressed into a sum of sinusoidal functions. That's what we are going to do. For example, if you see the output is here like this, a function, a constant function for two different intervals, isn't it? Maybe when you draw one component, if you draw one component, maybe it will be a sine function like this. And if you add two harmonics, it will be looking like and when you write more harmonics, the the curve will look like at the end straight line, in this line. So for example, if you hear some symphony, there are many violins are playing, isn't it? And if you want to separate all the violins into different parts, the output of every violin should be separated from the music. That is called a Fourier series. Actually, we are expanding the function to its terms, components. We call it harmonics, right? So we are finding the functions that are involved in the building of the front view. Okay, that's what we are going to do. I think the idea is passed. Is it clear? If not, inform me in the discussion session. We will discuss further, right? Fine. Here we find the formula. This is the formula for Fourier series. Any function that satisfies the Dirichlet's condition can be expanded by using this formula. Here this involves two different series. One is cosine series, another one is sine series. Summation an along with the cosine and bn along with the sine. N pi x over p is the theta. These three constants a0, an and bn should be separately found and should be used in this set. That's it. If you find a0, an and bn, you're done. So what is going on here? This series, this set we have already seen in the last chapter. Which is this series, this set is an orthogonal set in the interval negative p to p. We have proved it in the last session. This set will be special importance later in the solution of the boundary value problems. What we are going to do here is to expand a function f defined in the magnitude p and t in an orthogonal series that involves all the terms of this series, isn't it? Consisting of the trigonometric functions in one. That's what we are going to do here. So finding the formulas are again written. This is the formula for field series. Here what is A0 is given here. How to find A0 is in direction of f of x with respect to x from negative p to p, and divide the answer by p. P is the half length of the interval, you know. The interval length is negative p to positive p. Okay, so total length is 2p. P is half the length of this interval. An, take f of x, integrate with the cosine, cosine n pi x by p from negative p to p, and divide by p. That will give you an, the constant. And another bn, take the same f of x and integrate with the sine, divide by p. These constants a0, an and bn are called Fourier constants. Fourier constants. So once you find all these three terms, you are almost done. Substitute them in the equation number 8. That's all. Next is convergence of a Fourier series. What the statement? Let f and f dash be piecewise continuous in the interval negative p to p. That is, let f and f dash be continuous to the expansion. Isn't it? Piecewise continuous. We want them to be piecewise continuous in the interval. Then for all x in the interval negative p to p, the Fourier series of f converges to f of x at a point of continuity. But at the point of discontinuity, the convergence is the average value of the left and right limits. What do you understand from this one? Let us take a function f of x. F of x is equal to negative 1 and positive 2. Negative 1 in the interval negative pi to 0 and positive 0 to pi, positive pi 2. When you draw the graph, you will find that the xy plane, this is negative 1, this is negative 2, negative 2. So negative 1 is here, 1 and 2, positive 2 is here, isn't it? This is negative pi and this is positive pi. The point of discontinuity is 0. At 0, you don't have a common value, isn't it? Point of discontinuity is 0. All other points in the interval negative pi to pi, the function is continuous. So it is piecewise continuous, isn't it? F and f dash are piecewise continuous. Okay, now the question is, what is f of pi by 2? Pi by 2 is lying between 0 and pi by 2, isn't pi, isn't? So this will be pi by 2. Whatever the value of pi by 2, the answer is 2, because it's a constant function. F of pi by 2 is 2. F of negative pi by 2 is negative 1. So for continuity, you will find where f of x is converging to. But at the point of discontinuity, what is f of 0? That's the question. F of 0 is f of 0 plus f of 0 minus divided by 2. That is left limit at 0, right limit at 0 divided by 2. Left limit, when you fall a little bit left to the 0, the answer is, you are in the first interval. The answer is negative 1. Isn't it? When you fall to the right of 0, 0 plus is positive 2, 0 minus is negative 1, and divided by 2, the answer is 1 by 2. So this is the concept, how to find the value of f(x) at the point of discontinuity. Let's start the first example. Find the Fourier series. Here there are 5 problems, 1 to 5. For all problems, we are going to find a Fourier series of f in the given interval. That's it. So first time we will write the formulas. Formula for Fourier series is f of x is a0 over 2 plus summation n from 1 to infinity cosine with an into cosine n pi x over p plus summation. I separate the summation for two different series, n from 1 to infinity bn sin n pi x over p. This is it. Here we want the values of an, bn and a0. I start with an, finding the value of an, because sometimes n can be replaced as 0 to find a0 value but not always, only on some special cases, if n is possible to take the value of 0. Okay, an is, the formula for an is 1 over p, integration from negative p to positive p. We take the f of x and integrate it with the cosine. F of x cosine n pi x over p dx. Take what is f of x? Now in this look at this given problem. From p is, what is your p? P is pi from this problem, because negative p to p. So the interval, given interval must be negative p to p. So it is pi. Half length is pi. So when you substitute them here, 1 over pi, and this negative pi to pi can be separated into two parts. First part is negative pi to 0, where f of x is negative 1. Cosine n pi x over p dx. P is pi. P is pi. So this pi and this pi can be cancelled because they are all inside theta. Second term is integral 0 to pi. The function is 2. Function is 2 in this interval. 2 sin n pi x over pi. P is pi dx. So the next step, what do you get? An. Here I am writing 1 by pi integral negative pi to 0 negative cosine nx dx plus integral 0 to pi 2 cosine nx dx. This is not sine, this is again cosine, the same function cosine. We are finding an, as far as we are finding an, everywhere it is cosine, not sine. Sine will appear for bn. This is f of x. Okay. So now integrate it. 1 over pi. 1 over pi is outside. This one is negative outside. When you integrate cosine, it is minus. When you integrate cosine, it is sine. Sine nx over n. From 0, negative pi to 0. Plus 2 times 2 is constant. When you integrate cosine, it will be sin nx over n from 0 to pi. Since the integration answer is sin 0 is 0, sin n pi is 0. Therefore, all the terms will be 0. And you remember sin n pi, n is negative or positive integer, it is 0. Here we take n values are integers, not non-integers. Only integers will be considered for n. So sin n pi will be 0. Therefore this an is 0. Since an is 0, we cannot conclude about a1. So we separately find a1 in a different sheet. Here I will find a1. A1, the formula is 1 over p integration minus p to p f of x dx, where p is pi, is 1 over pi integration negative pi to pi f of x dx. Further you can expand the interval 1 over pi, open the interval, negative pi to 0 f of x is negative 1 dx plus 0 to pi f of x is 2 and dx. Integrate and get the answer 1 over pi. Here you will get negative outside. X is the answer, the negative pi to 0 limit plus 2. X is 0 to pi. So what you get finally 1 over pi. This will be 0 minus pi. For second term it will be 2 times pi minus 0. So simplify, what you get here negative pi, here 2 pi, the answer is minus pi, answer positive pi over pi, the answer is 1. So we found so far n is 0 but a1 is not 0, a0 is 1, isn't it? Now we have to find bn. The formula for bn is 1 over pi integral minus pi to positive pi, take f of x, integrate with the sine n pi x over p. The p is pi, isn't it? Pi dx. So 1 by pi f of x in the first interval from negative pi to 0 minus 1. Pi and pi can be cancelled in sine. You will get sine nx dx plus integral 0 to pi f of x is 2 sine nx dx. Now integrate 1 over pi. First integration will give you, this is open bracket, outside bracket, negative 1 is outside, negative is outside. Integration of sine will be minus cosine nx over n, and from negative pi to 0, so take the negative outside, right, it will be positive, plus 2 times minus cosine nx over n from 0 to pi. What you get here is 1 over pi. This will be positive, first time is positive. 1 by n can be taken from both the terms, so 1 by n pi outside. This is cosine x is 0, cosine 0 is 1, minus x is negative pi cosine n pi, plus 2 times minus, because minus is outside, cosine n pi minus cosine 0 is 1. Okay, you now simplify further, you get bn is equal to 1 over n pi. This term is 1 cosine n pi. Remember, cosine n pi minus 1 to the power n. The coefficient of pi will be in the power of negative 1. So you get 1 minus minus 1 to the power n. Go to the next one, check. Minus 2 times cosine, isn't it? Minus 2 times minus 1 to the power n plus 2. So you will find that the answer of bn is 1 over n pi times 2 plus 1 plus 2, which is 3 minus 3 times minus 1 to the power n. 3 can be taken outside, so 3 n pi 1 minus 1 to the power n. This is one answer of bn. In other words, we can write bn as, if n is odd, put n is odd in this equation. For n is odd number, minus 1 will be minus 1. Minus 1 to the power odd number is minus 1. So minus minus plus 2 into 3, 6 over n pi. Isn't it? N will remain n, but this minus 1 will become minus 1. Minus 1 to the power n will become minus 1 when n is odd. When n is even, see, minus 1 to the power n will be positive 1 and 1 minus 1 will be 0. So 0. Bn is available only for odd values of n. That's the point. You can use either this one or this one in the final answer. Final answer, we will write f of x a0 over 2 summation n from 1 to infinity an cosine nx, because n pi x over pi will be cancelled. Summation n from 1 to infinity bn sin x. The pi gets cancelled because p is also pi. Okay, now what is a0? A0 is 1 over 2 plus an is 0, so everything is 0, n is 0, everything is 0. Bn, summation n from 1 to infinity bn is we can directly use we can use the first form, 3 over n pi to 1 minus 1 to the power n sin nx. Further, I will replace this value by its, I write n is 1, 3, 5, 7 is going odd number to infinity. I take only n is odd numbers. So 3, this becomes minus 1 and 6 n pi, 6 over n pi. Sin nx. Still further we can expand it. 1 by 2, when n is 1, what happens? 6 over pi sin nx, sin x. When n is 2, 2 is not available, 3, because this term is valid only for odd numbers of n. So what do you get? N is 2, n is 3, 6 over 3 pi sin 3x. N is 5, 6 over 5 pi sin 5x. In this way it's going on. So the function given to us is the combination of all sine functions in this form. That's the meaning. When you add sine components, go to the website Math315-week11-part2 and check. When you first draw f of x is equal to 1 by 2, what graph you get? And when you add 2 harmonics together, what graph you get? When you add 3 harmonics together, what graph? When you add more harmonics, the graph will be almost equivalent to the original function. F of x is given as minus 1 and positive 2 in the interval negative pi to pi. You understand it? So we are separating the function into its harmonics by using Fourier series. That's the end of this problem. We'll go to the second problem. The answer is here. Problem number 2. A different function has been given. I'm not writing the formulas, I'm directly going to the so let's first find an. The formula for an is here. What is p? P is 1. Check the limit. It's minus 1 to plus 1. So say p is minus p2 plus p. So p is 1. An is 1 over 1 integration negative 1 to 1 f of x cosine n pi x over 1 dx. So what we get is negative 1 to 0. It is 0. F of x is 0, everything will be 0. From second interval 0 to 1, x times cosine n pi x dx. Okay, when you find first term is 0, second term you have to integrate. You will find a n is only integral 0 to 1 x times cosine n pi x dx. We can use the formula integral u dv is equal to uv. Okay, and it's a different version of the same problem. Integration by parts in different format. Integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 if algebraic function is available along with the exponential cosine. You can use this format. It's going on, but we know what is u here. U is x, so u dash is 1, u double dash is 0. We don't need third term, we need only first two terms, v1 and v2. v is cosine n pi x. v1 integrate cosine is sine n pi x over n pi. What is v2? Sine, integrate sine, it will be cosine n pi x divided by again another n pi, so n times pi whole square. These are the terms to be used in the integration. So on the left side you will find it, a n is equal to u v1, u is x, v1 is sine n pi x over n pi, and the limit is from 0 to 1, minus u prime v2. U prime is 1, v2 is negative cosine n pi x over n pi. This is common divisor, 0 to 1. And this minus and minus will be positive here, right? First term x is 1, sin n pi will be 0, so everything will be 0. X is 0, everything will be 0. First term gives everything 0, plus cosine 1 over n pi, 1 over n pi, isn't it? So here v2 is n square pi square whole square, n pi whole square. So this will be n pi whole square. Cosine x is 1, cosine n pi minus 1 to the power n, and cosine 0 minus 1. So the answer for an is 1 over n pi whole square minus 1 to the power n minus 1. And again we can check for even and odd values of a n, isn't it? We can do it later on. Now we cannot find a0 from here because n is the denominator. We should use separate sheet to find a0. We'll find a0 here. a0 is 1 by 1 integral minus 1 to positive 1 f of x dx. So we will write it as minus 1 to 0, the function is 0 dx, plus 0 to 1. What is the function in the given interval? F of x is x into dx. You get it x square over 2. From 0 to 1 it is 1 over 2. Therefore the answer a0 is 1 over 2. We got two terms, and the question is what is bn? Formula for bn, 1 over p, 1 over 1. So negative 1 to 1 f of x sin n pi x over 1. P is 1, isn't it? Remember it, dx. So what is it? From first interval it is 0, second interval it is 0 to 1. First interval minus 1 to 0, the function is 0, so everything is 0, leave it. 0 to 1, f of x is x sine n pi x dx. Use the same kind of integration. Same kind of integration by parts. U is x, u prime is 1, so we don't want u double prime is 0, so this is left. V is equal to sine n pi x, v1 is minus cosine n pi x over n pi, and v2 is minus sine n pi x over n square pi square. We use them in the formula integral u v dx, which is equal to u v1 minus u dash v2 plus, so going on only first two terms we are looking for. So substitute them in b. So bn is, what is u, what is v1? U is x, v1 is negative cosine n pi x, x negative cosine n pi x over n pi, the limit is from 0 to 1. Next term comes with the negative sign, so negative u prime v2, u prime is 1, v2 is given here. Negative u prime is 1, negative sine n pi x over n square pi square 0 to 1, isn't it? Yes, negative sign will be positive. So here negative is outside. When x is 1, this will be cosine, this is 1, this will be cosine n pi. Cosine n pi will be minus 1 to the power n, and when x is 0, everything will be 0. So this is minus 1 to the power by n pi. Minus and minus will be plus. When x is 1, sine n pi is 0. When x is 0, everything is 0 again. Zero. So what we get here is this term is 0, n pi in the denominator, minus 1 to the power n, again a minus 1, so minus 1 to the power n plus 1. This is bn, isn't it? So we got all the three terms. Now we substitute in the function f of x. A0 is 1 by 2, 1 by 2 over 2 plus summation n from 1 to infinity. Write the an as it is. Isn't it? We don't need to. I just shown in the last problem how to expand, how to write for odd and even values. You can straight away write the same value what you got. This is an cosine n pi x divided by 1, isn't it? But p is 1. Third term, summation n from 1 to infinity minus 1 to the power n plus 1 divided by, this is bn, n pi into sin n pi x. That's the end of this problem. If we want, we can further check whether this is true for odd values or even values and then simplify. So this function has both the cosine and sine series. Okay. Next problem. Problem number 6 from your textbook. Pi square minus x square in this two interval. What is p? P is pi, negative pi to positive pi. P is pi, isn't it? And formula of an starts from here. 1 over p. P is pi, 1 over pi, from negative pi to positive pi, f of x cosine n pi x over pi dx, and this pi can be cancelled, both are inside it, isn't it? What we get is 1 over pi integration from negative pi to 0. The function is pi square, which is a constant, cosine nx dx plus 0 to pi. The function is pi square minus x square. The function is variable x, the cosine nx dx. The second part of the integration should be integrated by integration using the concept of integration by parts. Okay, first integration will be, so here what to do, u is pi square minus x square, u prime is minus 2x, u double prime is minus 2, u triple prime is 0. So we will have three terms, v1 cosine nx, v which is v1 is integration of cosine minus positive sin nx divided by n, v2 integration of sin will be minus cosine nx divided by another n square, and v3 minus sin nx divided by n cube. Therefore the formula for second, we will write everything here. And first integration outside is 1 by pi. First integration will give you constant pi square as it is. Cosine will give you sin nx cosine will give you sin nx sin nx over n, this integration, isn't it? And the limit will be from negative pi to 0. When sin nx is there, negative pi and 0 both will give you 0, isn't it? Plus the second integration now using uv formula. The formula is integral uv dx, which is u v1 minus u prime v2 plus u double prime v3. We have only u double prime, u triple prime is 0, only 3 times. First term u v1, u is pi square minus x square, v1 is sin nx over n minus u prime is minus 2x, and v2 is minus, so both will be positive, there is a negative, totally it's negative, cosine nx divided by cosine nx into 2x, u prime is 2x, v2 is minus cosine nx over n square. Finally there should be plus here in the formula, but u double dash is negative, v3 is negative, so again you will get positive. See, 2 sin u double dash is negative 2, v3 is sin nx over n cube. The entire limit is from 0 to pi. Now I erase some parts so that the integration can be solved here. This first term will be zero. Second term, substitute pi here, it will be 0. Pi here, 2 pi by first term is 0, second term starts from 0 for upper limit, 0 minus cosine n pi will be minus 1 to the power n, and 2 pi over n square plus sin n pi is 0. This is for upper limit minus lower limit. Sin 0 will be 0, cosine 0 will be 0, again everything will be 0. So you get 2 pi divided by pi will be cancelled here. So you get minus 1 to the power n 2 divided by n square, because this pi and this pi will be cancelled. Minus, this is minus 1 to the power n minus again a minus 1, minus 1 to the power n plus 1. This is our an, and we cannot find a0 because n in the denominator. A0 should be separately found. The formula for a0 is 1 over pi here, from minus pi to plus pi, integrate f of x dx, 1 over pi, there will be minus pi to 0. What is the function? Which is pi square dx plus integral 0 to pi which is pi square minus x square into cosine nx. No cosine nx, there is no cosine actually. We are integrating only f of x dx. Check your answer. What you get here is 1 by pi. This will be pi square times x from 0 to negative pi to 0. Here integration will give you pi square x minus x cube by 3 from 0 to pi. Simplify this one, you will get the answer is 5 pi square over 3. This is your a0. Now I am leaving finding bn to you. You know the formula again. I have to use the formula. Just 1 by 5 from negative pi to 0 pi square sin nx, n pi x over pi, isn't it? Plus 0 to pi square minus x square, again sin nx dx. Here you can use integration by parts. You can directly integrate this first part, and the answer you can check. The answer you can check as pi times minus 1 to the power n over n plus 2 over n cube pi into 1 minus 1 to the power n, isn't it? Now we substitute all this term in the function f of x. a0 is 5 by 3 pi square divided by 2. So this 3 joins the 2. The next step, summation n from 1 to infinity an is 2 over n square minus 1 to the power n plus 1 cosine nx, plus the third term is summation n from 1 to infinity sin. This term should be written here bn. This term should be written here sin nx, where bn is given here, isn't it? This is. So that's the end of this problem. I have one more problem to solve. Here we will start with the formula of an. We find 1 over pi because p is pi. And the first part it is 0, so 0 to pi, the function is sin x, and then we should use cosine n pi x by pi, so it will be as cosine nx dx. And we should use the formula that we have discussed the last topic, cosine a sin b, isn't it? Sin a cosine b. This formula, there is a formula, sin a cosine b is equal to 1 over cosine a minus b minus sin a cosine b, 1 over sin. See, this one is slightly misinterpreting. The formula is sin a cosine b is equal to 1 over 2 sin a plus b plus sin a minus b. This formula will be used here to find an. One over pi, this sin a cosine b, use this formula, right? So it will be integral 0 to pi, integral 0 to pi sin a cosine b can be written as 1 by 2. 2 can be written outside. Sin a plus b, this is a, this is b, a and b, so sin a plus b, sin x plus nx plus sin a minus b, sin x minus nx dx. Now we can easily integrate this one. 1 over 2 pi, integration 0 to pi, what we get is sin 1 plus n times x, that is the theta. The quotient of x is 1 sin, plus sin 1 minus n times x dx. So integrate it, you will get 1 over 2 pi from this one. What we get, integration of sin is minus cosine minus cosine 1 plus n times x over 1 plus n. Here again minus cosine 1 minus n times x over 1 minus n, and from 0 to pi. And we should carefully take the upper and lower limit. I will write it here again. We are finding an. An is 1 over 2 pi. Integration has been done. What did you get? Minus, can you check, minus cosine 1 plus n x over 1 plus n minus cosine 1 minus n x over 1 minus n from 0 to pi, 0 to pi. So substitute upper and lower limits. You get 1 over 2 pi. What we get, cosine n pi will be, keep the minus outside, cosine n pi will be n plus 1 pi will be minus 1 to the power n plus 1. Again, for this term, I take minus outside from both the terms, so keep the minus outside, positives will be there inside. We will check what we do. Pi will give you this one, minus 1 to the power n plus 1 divided by 1 plus n plus, again this one will be minus 1 to the power 1 minus n since the cosine is here you will find 1 minus n divided by 1 minus n, and this is for upper limit. Minus cosine 0 will give you 1 over 1 plus n plus, when you take both the negative outside, this will be plus 1 over 1 minus n. Now we have to carefully do it. 1 over 2 pi. I take minus 1 from every side, this will be positive. I take a minus 1 outside, so what happens here is minus 1 to the power n over 1 plus n, and here it will be positive, so it will be plus 1 over n or 1 plus n. Again this term will be minus 1 to the power minus n, and it can be written as minus 1 to the power n plus 1 over 1 minus n. Now when you simplify, this outside will be 1 over 2 pi. When you take out the common term 1 plus negative 1 to the power n, the remaining term will be 1 over 1 plus n plus 1 over 1 minus n. So take LCM of these two terms, you will find the answer the next time. 1 over 2 pi, this will be 1 plus minus 1 to the power n, and when you simplify here 1 minus n plus 1 plus n, it will be 2 divided by 1 minus n square. 1 plus n, 1 minus n will be 1 square minus n square. So in the next step we will write the answer B. We are finding an is equal to minus 1 to the power n plus 1 divided by pi times 1 minus n square. This is our an. Now we got to find a bn. And first check whether you can do n equal to 0. See here one more information is, here n square, n is not equal to 1. Therefore this formula is not good for an. Will not give you a1 value. So a1 should be separately found. The formula is, in the formula of an, 1 over p minus p2 plus p f of x cosine n pi x over p dx. Put n equal to 1, you will get the formula for a1. a1 is 1 over p from minus p to p and still this answer is not true for n equal to 1, isn't it? So because n equal to 1 will make this one 0, and then everything will be infinity. Okay, when you substitute upper, since these are the sine functions, substituting upper limit as pi and lower limit as 0 will give everything as 0, but not for, so bn is 0, but not true for n equal to 1. So separately we should find b1. The formula for b1 will be 1 over pi from again 0 to pi. F of x is sin x and again sin n pi x, n is 1, n pi x, n is 1, and pi will be divided by pi sin x dx, and it will be 1 over pi integration 0 to pi. Sin square can be written as 1 minus cosine 2x over 2 dx. So it will be 1 over 2 pi integral 0 to pi. So integration will give you x minus, and integration will be sin 2x over 2 from 0 to pi. What you get, 1 over 2 pi, upper limit will be pi minus sin 2 pi is 0 minus x is 0, sin 0 is 0, so it should be 1 by 2. So b1 will be 1 by 2. How do you write the function? You should recall a0. What is a0? Did you find a0? a0 is 1 by pi integration from 0 to pi f of x sin x dx. So it will be 1 by pi minus cosine x cosine x from 0 to pi, 1 by minus 1 by pi cosine pi is minus 1, cosine 0 is so it's 0, so minus 1 minus 2, and the answer is 2 over pi. So we have to collect all this information to write in the function f of x. F of x is a0 over 2 plus a1 we will write with the cosine 1 cosine x, 1 pi x by pi, isn't it? And plus summation n from 2 to infinity an cosine nx. Next b1 sin x plus summation n from 2 to infinity bn sin nx. But we know that a1 is 0 and bn is also 0. So what we get, a0 is given here. A0 is 2 over pi over 2 plus a1 is 0, this time will be 0, so you can write this one, n from 2 to infinity an. an is 1 plus negative 1 to the power n pi into 1 minus n square cosine nx plus another term, this one b1 is half, so plus half times sin x. That's the end of this problem. We have one more problem to continue. Draw the result in problem number 9. Previous result show that this is true. Here f of x is given as 0 and sin x. 0 in the interval negative pi to 0, sin x is from 0 to pi. So we are going to give some value for x in the Fourier series expansion f of x. F of x, I'm writing the Fourier series expansion one more time. This is 1 over pi plus 1 by 2 sin x plus summation n from 2 to infinity 1 plus negative 1 to the power n divided by pi into 1 minus n square cosine n pi. Now x is equal to some value between 0 and pi. So I give x is equal to pi by 2 because it is continuous in this interval. So f of pi by 2, the left side 1 by pi plus sin pi by 2 is 1, so it is 1 plus summation n from 2 to infinity. So we can check this for even and odd values. You will find that an for even values of n, this will be positive 1, so 2 over n into 1 minus n square. For odd values of n, it will be 0. So we are going to consider n as 2, 4, 6 to infinity. Cosine n x actually here. X will be pi by 2. Now you have expanded. F of x pi by 2 is sin pi by 2. Will be 1 on the left side. This can be found from this function. Now 1 by pi plus 1 over 2 minus, now give even numbers for n. You will find when n is 2, you will find 2 over this will be 2 into 1 minus n square. You can write this one as I again rewrite this one, then we will expand it. Summation n goes to 2, 4, 6 to infinity, 2 over, this is actually pi times 1 plus n into 1 minus n, we will write this way, and cosine n pi by 2. Cosine n pi by 2 is 0 when n are odd numbers, and there is no odd number for n, isn't it? So now expand for all n. 1, this is 1 by pi plus 1 by 2 when n is equal to 2. When n is equal to 2, you will get 2 plus 1, 3, 1 minus 2, minus 1. So this is minus 2 over pi into 1 into 3. Are you getting something like this with a different sign, isn't it? Next will be plus, because there will be negative here, and there will be plus here actually. When n is 2, this will be cosine pi is minus 1, cosine pi is minus 1, and there is a minus here, it will be plus, and then another term will be again plus or minus, check. 2 over 4, 4 plus 1 is 5, it's negative 3 here, so it will be negative, and 4 will give positive 1, so it will be 2 by pi 1 over 1 3 into 5. You will find this term, isn't it? The common term is 2 over pi. You can take it outside. In this way it's going on now. You can find 2 over pi positive 1 over 5.7 minus 2 over pi negative 1 over 7.9. This way it's going on, isn't it? So in this sheet we will finish it. The left hand side it is 1, 2 over pi plus 1 over 2 plus 2 over pi into 1 into 3 minus 2 over pi into 1 over 3 into 5 plus 2 over pi into 1 over 5 into 7. It's going on this fashion. So this half should be subtracted on the left side. It will be 1 minus half, it is half. Now 2 by pi can be taken common. You will write 1 plus 1. Let us check that PowerPoint deck. It is 1 by pi at the beginning. It's not 2 by pi. 1 by pi at the beginning. So I have miswritten that one. So it is 1 by pi here, right? So when I take 2 by pi outside, there will be 1 by 2 here. Now the second term will be 1 over 1 by pi. Third term minus 1 over 3 times 5 plus 1 over 5 times 7. It's going on, right? So what do you get here when you take this one? Pi by 4 is equal to 1 by 2 plus 1 over, take this to this one, minus 1 over 3 dot 3 into 5 plus 1 over 5 dot 7. It's going on this fashion. This is what the given series. That will be ending this chapter. Thank you very much.